Hey everyone, day 11 of Advent of Code 2025 today. Yeah, not starting super early today, only about a minute to spare, so I'm actually gonna quickly do my setup. I guess I've never really shown this, but it's also not much of a setup. I just copy over a couple lines I think might be useful, and just call it there, and then get rid of some of the old lines, make sure I'm set my thing to, go for the right file, and then leave around the input. Actually, one thing I did want to talk about, kind of annoying. Man, I feel like sometimes it's always so frustrating getting mail. Like it's kind of a modern marvel that we have the mailing system we have. You can just put in an address and boom, it gets its destination. But also sometimes it's just really annoying, man. I waited the whole day today at home for this UPS package. Like literally just spent the whole day, didn't even go to the office, and waiting for it. And they just said, oh, recipient was not home. I was like, what? I was home the whole time. Didn't hear a single person knock on my door, ring the doorbell, or anything. Crazy stuff. Okay, what is this problem? How many paths get you out? Oh, okay. I mean, this is a graph problem, right? So we have let's just do a class node. Hopefully I don't have a class already called node. So string name and then list of string child nodes. I don't know, maybe not the greatest name, but it'll do. Public node. What do we want? We want how do we want to split this? Yeah, by space is fine. String array align. And then we do name equals lines 0 dot substring 0 comma, what is that? Line 0 dot length -1. We just want to get rid of that last colon. And then the others, we can just do for int I equals 1 and do it that way. We do child nodes dot add lines I. We could also have child nodes be an array, but I like the idea of using a list so we can do like dot contains and stuff if we need to. So now we have a list of nodes. Oh, speaking of which, we should probably initialize child nodes, huh? And then we do nodes.add new node. Fine. Cool, so now we parsed it, and our goal is exit. Okay. BB to DD. Okay, I mean, I think it makes sense. I suspect the naive solution will be a bit slow, which is just BFS to the end. But we can give it a shot. So we have Q of node. Oh, actually, we probably want a path or something like that. Something of this sort. I'm going to use a DQ because I don't feel like implementing comparable. And then while the queue is not empty, we do something. Let's do node equals q.poll. If node.name equals, what is it? It's out, right? Out. Answer ++. Otherwise, for child, right? No, for string child, node.child nodes. We do, how do you do this? Node new node equals, let's just make a new one for this. Name equal, actually we don't need to set the name. We need to do child nodes equals new array list. Not quite like that. Child nodes not at all. Other.child nodes. Then we do path.addAll other.path. Cool. So we have new node equals new node node. New node dot name equals child. How do I do this? Maybe I maintain a map of nodes to their children. So what I do here is then do map.put node nodes.get last.name comma nodes.get last not dot child nodes. Cool. So a new node yeah, can't we just do this? Do we even need, oh yeah, sure, we'll have a public node. Do his name is child, then new node dot child nodes equals map.get child. What else do we need? Oh, new node dot path equal what dot add child. Like it's the last entry. Cool. And then we do q dot push dot add new node. Cool. And then you know what? We'll just system.out.println is. Let's see what we get for the example. I'm taking this day pretty slow, but I'm just curious. Ooh. Sure. 0, I love that. Oh, right. I never add the first element. Can I do add all nodes? Cool. Is there already an out? No. Okay. 30. Is 30 right? No, the answer is 5. The fact that there's U is also a bit concerning. Oh, I need to find me first. I see. Okay. So I'll make the Q first then. And let's make sure to exclude it from this logic as well. So we can do if nodes.child nodes, what? No, sorry, nodes.get last.child nodes.contains u. We can do then do q dot add. Something like that. Nope, still getting 30, right, because of this. Ooh, 5, okay. Cool. Now let's go to this. It's not great. Dot substring. Is there an empty space somewhere? How are you? Oh, wait, what? Wait, am I crazy? Why is there a space there? Oh, I must have just copied it wrong. That's crazy. Wait, brute force just worked? Oh, no, it's not right though. Huh. Two, 2, 1, 5, 2. Why did my thing break? Hello? Intelligent? Do you want to respond? I'm surprised it's not 2, 2, 1, 5, 2. Interesting. Are there multiple U's? Oh, there are multiple U's. Wait, which one is the right one? Am I supposed to consider everything with a U? Oh, maybe just if the, wait. Oh, whoops. I'm not being smart here. It's the one that literally has the name U. No, not this. It's if nodes dot get last dot name dot equals U. Q dot add node dot get last. That's way smaller. Okay, sick. That was not bad at all. Both DAC and FFT. Oh, interesting. Okay, so we now, instead of U, we start at server. First of all, how much does this return? Oh, that's bad. Okay. Oh, I wonder if there's loops. Okay, but regardless if there's loops or not, we need node.path.contains DAC. Node.path.contains node.path.contains, what was it? FFT? FFT. I've never heard of it. Oh, actually, digital analog converter, I have heard of that. FFT is fast Fourier transform. I think I use that in college a bit. Not frequently, but sometimes. Cool. Yeah, we gotta deal with the fact we're looping somehow. I assume all the loops... Oh, we probably should get rid of this as well. Yeah. It's definitely looping. Okay. How do we check for loops? If... No, right here. If new node dot path... Oh. should put it before. If node.path.contains child, we've already seen it, so continue. Oh, interesting. It's still massive. Ah, why? Let's print out what it looks like. Kind of curious, huh? Oh, I'm never. Oops. New node dot path dot add all node dot path. Okay, now we have actual paths. I guess I should really have these paths like the path should probably contain itself, huh? So we can do path dot add name. Yeah, so every path starts with server. And just goes and goes. Seems incredibly slow. We haven't found a single path to out yet. Let's do a little bit of analysis of the output. There's a lot of things that go to out. Okay, what about FFT? Well, there's not many things that go to FFT. Just 3. How about DAC? Ooh, it's kind of similar. Not many things that go to DAC either. Okay, I mean just to be sure, let's just try the sample, just to make my approach at least works. Yeah. Okay. Cool. So it's just the efficiency thing. So why is my thing so slow? I'm so confused. Like, CPU is okay. Actually, my CPU is going absolutely insane. Makes sense, I guess. We're just like trying to brute force this thing. How can I make this more efficient? Because if I start a server, right, there's a bunch. And where does Tra go? Yeah, Tra goes to a ton of stuff. Oh my goodness, KPE goes to even more things. GBR goes to a bunch of stuff. Absolutely insane numbers of things. Okay, what if we start it out? Can't really do that. There's 27 things that have out in it. What we could do is get all the paths from SVR to FFT, right? Like, is that doable? And then for now, we'll just comment this out. Like, how long does that take? Okay, so we have 6296, and then we want FFT to DAC. Interesting. Oh. Wait, does it have to be in order? Oh, in any order. Okay. My goodness, there's a lot of stuff that goes from FFT to DAC. Holy moly. That's kind of insane. And they're not loops either, because we... Oh, wait, I'm trolling. This should be child. Okay, I don't know if that mattered. But I think that's it, right? We can just do the parts pathwise. I would say that's a lot faster, except this is still agonizingly slow. I might just open a separate thing to keep track though. So we have, ignore that nonsense. We have SVR to FFT, SVR to DAC, DAC to FFT, FFT to DAC, FFT to out, DAC to out. I think once we have these, we can do, let's call this A, B, C, D, E, F. So we could go SVR. Oh, dang, I just closed it. I don't know what the value is. Okay. It's kind of unfortunate. This is already gigantic, this number. It seems to still be going up too. Okay, so FFT to DAC is humongous. Let's see, is there any DAC to FFT? What? How is that even possible? Like, which node is this? Oh, out. Wait, what? Okay. Yeah, if okay, we just skip this case. Okay, so there's nothing from DAC to FFT. So this path is actually just 0. Which means we have to go to FFT first. Right? And then we can just do, so DAC to out. Okay, DAC to out is 5,000 something. And then SVR to FFT (6296). I'm gonna let it run for a bit to be sure, but 6296. Okay, cool. And now we can do FFT to DAC. Oh, I wish I had a good visualization of this. I assume that it's mostly one way. Like certain nodes. Actually, can I assume no loops? Because if so, I wonder if I can ever say like, oh, this is out of the path. I don't know an easy way to do that. Okay. It looks like it's definitely 6296, by the way. I feel like we're quite good there. Now do FFT to DAC. there an intelligent way to do that? I mean, we can remove a bunch of nodes, right? Like any node that predates FFT cannot be used. Any node that postdates it cannot be used. Yeah, actually, we can just do that, right? So let's have a bunch of queues. We're gonna have 3 queues. And basically we do, if we're gonna treat FFT as the final one, I think, DAC as the second one, and then SVR as the first one. Oops. Okay, and then we'd have a set of strings, which is basically scene. So these are the ones we shouldn't use. So basically what we can do is we have, well, the first queue is not empty. We go for what, SVR. Now let's do DAC to out as the first one. So let's make this queue 2 actually. So DAC to out. And then, yeah, if node equals out. So if node equals out, right, we answer plus plus. We need 3 answers as well. So long answer 1, long answer 2, long answer 3. This might get too big for longs actually, so I'm just gonna return them as strings, which is kind of crazy, I know, but we're gonna do that. So we're gonna do answer 1. Wait, I'm Q1. Sorry, Q1, Q1. All right, and then scene.add all node.path. Scene.remove DAC, because we do need DAC for the next one. Cool. And now that we've done Q1, we've now eliminated a bunch of things. So we can do, I'm actually going to jump to Q3 just to try it. Might fail, it's fine if it does. But what we're gonna do is, so Q3 is FFT to DAC. What we're gonna do is do or scene.contains child. I'm gonna try to bypass a bunch of stuff. 5034, yeah. I realize I don't know what I'm printing at this point. Also, I should be incrementing answer too. Let's just, oh sorry, that was me looking at stuff for yesterday. Nope. Do a little bit of this. Really? You're not just going to tell me the answer? There we go. think that's this. So let's just try multiplying these together. It's a bit manual. I'll make it work in code if this does work. Oh, don't give me that. Alright, wait 1 second. Let's do system.out.println. Actually, no. Let's do return. Oh my goodness. Let's try that. Dang it. Okay. So the sort of my attempt at sort of cheating the problem didn't work, which is fine. Got a good shot, right? So we do Q3. No, we're gonna need a separate queue. So we'll add this to scene 2. Okay, let's see how it goes. So answer 2 equals 0. Okay, answer 2 now equals some massive number, as expected. Let's see if it ends up being 177 something. It does not. Okay. We're going bigger. That's fine. Let's see where it ends up. Oh yeah, it's really going. Okay, I was way underestimating it apparently. Oh, computer's on fire. Cool stuff. We'll give it another minute or two. See if it eventually settles at a number. Dang, it's still going up. This FFT to DAC really has an insane amount of connections. You know, I guess this is a good time to keep talking about the UPS thing I was talking about before. Yeah, I stayed home the whole day. I worked from home today. Waiting for this package. I was just refreshing the UPS tracking thing, and then it just goes, you know, oh, we missed you. We tried to deliver, but no one was home. And I was like, what? Oh, I ran out of heap space. Well, that is unfortunate, huh? That's crazy that I ran out of heap space. I'm not gonna lie. Wow. Okay, I mean, the number is gigantic. Fair, fair. Okay, let's do the other queue then first, huh? So we do Q2, which starts at SVR. So it should go SVR to FFT. Let's see how this does. 0. Well, I don't know, right? Why is it 0? SVR to FFT. Oh boy, does this mean there's nodes that are both involved in DAC to out as well as in SVR to FFT? Is that possible? I think it is, unfortunately, huh? Oh, that's frustrating. Wait. No, it's because I'm adding to the wrong queue. Never mind. Yeah, 6296. Again, I'll let it run for a little bit, but I suspect that's going to be it. And then basically what I want to do is have while Q3 so it goes FFT to DAC. And we have just more nodes to not consider. Hopefully it speeds up things a little bit. I don't know if it will, to be clear. Oh. Yeah, forgot to do the switch again. Like, I don't know if this is actually going to be faster, but I'm hoping it is. And last time we got to 500,000 before running out of heap space. Let's see how this does. Maybe we also run out of heap space at 500,000. The annoying part is it's hard to know what to prune. Oh, we got above 500,000 at least this time. How's our RAM looking? Oh yeah, that's bad. Yep, we're really using all of it, huh? Well, not quite. We still have 11 gigs free, but I assume that IntelliJ doesn't have my entire memory, right? Like there's some other Java heap space thing that's gonna break first. Yeah, it seems like now is probably where it breaks, huh? I mean, hey, I could try this number. It's much higher than the old one. Yeah. Online Python compiler. This is so stupid. I'm using Python just to print a number. But I don't want to interrupt this. So we're going to do 6296. Was it 5034? It was. Alright, let's try this number. Dang. Oh yeah, it got bigger. Oh, unfortunate. This number is gigantic. I wonder if there's a good middle point. Like, we care about FFT to DAC, right? Let's just look at some of the things. So FFT goes to, actually I was going to write this down. NQM NIG. Holy moly. I don't know if you can hear my computer, but it is dying up. Failed reallocation. Yep. Okay, cool. So NQM goes to those four. Yep. And what was the other one I want to do? NIG. NIG goes to these. Interesting. A lot of the same ones, huh? Okay. Let's take a quick look at one more layer down. And GC. I just realized if we hit the same one, like, surely we can just consider two paths at that point, right? Yeah, but we're not guaranteed. Oh man, how do I do this? I could have like a cardinality. Yeah, let's do that. Int cardinality. So what I could do is basically do if child. How do I do this? Like, I mean, I could search the queue, but that's big O N, right? To search a queue. Oh, it's kind of tricky. Because basically what I want to do is every time I hit the same thing, I remember that. And do like answer plus equals node.cardinality. And then here we have new node dot cardinality equals node dot cardinality, something like that. But how do I guess just a map, huh? Like a new hash map, something like that. And then each time I add something, I increment it. So Q3 is f of t to DAC, right? F of t to DAC, yeah. So we do cur cardinality dot put f of t is 1. Cool. And basically, if child, yeah, if cur cardinality dot contains key child, int original equals cur cardinality dot get child, original plus, we're gonna do cur cardinality dot put what is it, dot put original plus node dot cardinality. Oops, child comma. Not sure, whatever. Let's see. Otherwise, it's a new thing, so we do that. Does this make sense? I think so. It's like try this. Well, that's not great. I'm a bit confused here. I was like, I would have thought the cardinalities would sort of increase. Like MGC would have some cardinality. Yeah, I don't know. Like, what do we have at the end here? Like, where's MGC? I'm getting rid of some of these print lines. Not here. Let's go all the way down. MGC is 2. Does that make sense? Yeah? And then NQM is 1. Oh my goodness, I'm printing too many things. Where else am I printing? Here. Okay, NQM. Yep, NQM is 1. NIG should also be 1. Yep. MGC is 2. Where does MGC go? MGC goes to these things. Alright, so let's just look at those. CAS. CAS is 4. And somehow DAC is 3? Wait, so we're doing, sorry, FFT. Where else am I printing? Oh, here, okay. Get rid of you. I'm trying to get rid of some fluff. So DAC. Yeah, DAC is somehow 3, which is kind of ridiculous. That doesn't feel very possible. Oh, right, because we no longer want to. We no longer want to return on DAC. Well, we're not returning on DAC though. I think we just do nothing. Right, and then but then DAC is 3. Yeah, that's not crazy. DAC is definitely not 3. And yet somehow it is. Like, how do we get to DAC, right? Sorry. EEA. What is EEA? EEA is 3. Okay. What other ways is there to get to DAC? CVP. CVP is 2. Now that just doesn't make much sense, huh? if CBP is like, there's two different things that both can get to DAC, and yet somehow DAC is less than their sum. So when we first said it was CVP, oh, wait, what? So we increment CVP at some point. And that increments DAC. I'm starting to think a Q isn't even right for this anymore. I mean, I can still use a Q, I guess. Yeah, Q isn't bad, I suppose. Is there anything better? Like, what if I just did a list? Yeah, let's just do a list and see how it goes. None of this craziness. No? Oops, not that one. This one. What if we just had a list of strings? I don't even know what to call it. I'll call it buffer for no real reason. So do buffer.add FFT. Right, cardinality.put. And then what's the end condition though? I don't really know. I guess let's do this. Int limit equals, let's put it at 100,000. Or like, yeah, 100,000 for now. So while limit greater than, oh yeah, iterations, let's do it the other way. Iterations equals 0, while iterations less than, say, 100,000. What do we do? I guess and buffer dot is empty. Not is empty. We do string candidate equals buffer dot remove 0. Take our candidate, do for string children in candidate dot map, sorry, what was it, map dot get candidate. If sorry, child. If cardinality dot contains key child, cannot resolve child. Oh. We just do cardinality dot get child, right? So this is some value into original. Oh, I definitely deleted the wrong loop. Oh no, I just didn't delete any loop. Well, let's delete this loop for now. I'm trying to make this work. And then do cardinality dot put child original plus cardinality dot get candidate. Else cardinality dot put child comma cardinality dot get candidate, and then buffer dot add child. Dang. Dang it. Oh wait, no. DAC? That's not right. It's too low. Why would that be? Oh. Curious though. Let's just do a quick sanity check. What's NQM? 1. Good. What's MGC? 2. Okay. And DAC is just that? Really? That feels wrong. I mean, I'll try it. Oh my goodness. I didn't even copy the right thing. That's embarrassing. Oh man, I don't even know if I'm right or not. I guess we could try this for the other parts as well, right? Let's start with SVR. SVR. Curious what it gives. FFT. 524. Yeah, it's so low. Why is it so low? I guess it's because we can like further it, right? Like MGC ends at 2 or whatever it was, but it could have been 1 when it checked further. Yeah. Like you never know if you're done checking MGC. Okay, I'm gonna pause to get some water, but I'll be back in a couple minutes. I'm back. I'm gonna try to trace this out a little bit, just on a sheet of paper to try to understand it better. I mean, at the end of the day, I think this is a DAG, or a directed acyclic graph. Which means some Python dude, I'm sure, has come up with a 3-line network X solution. But this one feels a lot more doable than yesterday's problem. Even though you wouldn't think that given how slow I am at it. Maybe I'm just thinking about it wrong. Like, maybe I start at F and put in values in reverse. No, that doesn't quite work either, though. I guess, like, I'm doodling by rows, you guys can see it. Imagine this sequence, right? Imagine A can go to B or C, B goes to D or out, C goes to out. So if I iterate forward, and D goes to C. So if I iterate forward, I would start A at 1, then B at 1, C at 1, right? Now I go B to D, and so D is 1. But by this time, like, I now go C to out, so out is 1. It's just like the update order is not quite right. Because B updates D to 1, then C updates out to 1, but then D updates C to 1. I said to 2, but it's too late because out is already done. Like, I'm trying to think of a way to go backwards now. But it's also not very obvious, because then, like, out would go back to B, and you'd, like, sort of skip D in that line as well. Yeah. I don't know, it's very not obvious. I guess let's see the number of paths from point A to point B in directed acyclic graph. You need to use dynamic programming or recursion with memoization. Okay, let's see the solution. So du equals number of paths from U to target B. Sure. So you target memo. Count equals 0 for each neighbor of you. Count plus equals count paths. Oh, I like that a lot actually. Okay. I think I get the basic concept. What is this memoization? Memo u equals count. Okay. I think I get the basic concept. Yeah, let's try it with something we know the answer is. So SVR to FFT, or let's do DAC to out. So memo is basically going to be Kerr cardinality. Then we do, let's do answer 3 equals, what does it equal? Helper, our starting point. So we said we want to do what? DAC to out. DAC out Kerr cardinality, and then we're going to need the map as well. Ooh. Yeah, let's give it a shot, see how it happens. So we have now private long helper, string Kerr, string goal, and then map of string to integer cache. Right, so if Kerr dot equals goal, return 1. Else, map string to list of strings, map. Otherwise, for string child in map dot get Kerr, long answer equals 0, answer plus equals helper, child, goal, cache, map. And then we do cache dot add, dot put, Kerr, comma, answer, return answer. Oh, I should have made the cache long. Fair. If cache dot contains key child, answer plus equals cache dot get child, else we do the thing. How does this work? Okay, well, it worked brilliantly for DAC to out, but we already could do that one normally. So let's do SVR to FFT. Yeah. If child dot equals, no, it's because Kerr, right? If Kerr, how do I deal with that? If Kerr dot equals out, return 0. Okay, 6296, that's great. Now FFT to DAC. Wow, it's instant. Okay, now what about Actually, yeah, we have the 3 numbers. Let's do the thing. Make sure we actually have the number copied this time. Nice. Okay. Now, of course, we have all that. We can get rid of all this nonsense. Yeah, I looked it up, but I feel okay about that. We didn't end up using nodes at all. Did we? Not really. It's all good. I am going to change the name slightly. Okay, so what we can now do is if part 1 return helper u out cache map plus otherwise we want we do answer times equals helper svr fft cache map answer times equals helper fft DAC cache map answer times equals helper DAC out cache map. And of course at each stage we do need to clear the cache. I don't know if we actually need to, but might as well. And then return answer plus that. Let's see how it goes. Beautiful. What? How are we magically returning 0 for both parts? Hello? Map is still the same thing, right? Yeah, map sure does contain all the things. So, what happened? I mean, we definitely enter into it and then just give up? How does that work? Okay, let's just focus on part 1 for now. We start at U. Wait, I even see out in here, no? Yeah, multiple times. How are we ending with 0? Oh, because of this? So wait, I could just flip these, right? that right? 2-9 something? Yeah. So, okay. Wow. Honest, so it literally just was knowing the right algorithm, and then the problem is trivial. Crazy stuff. Sick. Well, I'm glad I looked it up. That's a cool thing. Yeah, I knew there's something like that. I kept trying to do with the Q and the cardinality stuff. I couldn't quite figure it out. But yeah, I mean, DFS makes a lot of sense here. Yeah, I'm slow as balls today, and that's alright. One last day. Alright, see you guys tomorrow. I actually finished part 2 for once, so yay me.